Welcome to the Crazy Hat Chemist. Alright, today is the 5th video in a series of 5 chemical reactions, and today we're going to be talking about net ionic equations. I'm going to give you 2 examples here today, one very long one and then one shortened version. So, here we go. Let's get right started here. So, these net ionic equations that I'm going to cover here today are just double displacement, double replacement. And here's the pattern. Remember, California plus California gives me a California plus a California. So that is a cation-anion combination. That's what the California is. Okay? For these type of reactions, you're going to have to look at solubility rules. One of the products is going to be either a precipitate, that's a solid, from your solubility rules, or it's going to be a heat or a gas. That also follows net ionic equations. And then I'm going to show you on the second example how to work backwards to get what you're interested in. Okay? But this is what you're going to see as a net ionic equation at the end. So you're going to see a C, that's for the cation. They're positively charged. They're going to be aqueous on the reactant side for these double displacement equations. And the anion, that's negative, and that's also going to be aqueous. And on the product side, you're going to have one product, and that's going to be a California. And that's either going to be a solid, a liquid, or a gas. And today, I'm just covering ones that follow the solubility rules that would be a solid. All right, so let's start off with the first example. Bam! Okay, here we go. Net ionic equation number 1. Silver nitrate is added to calcium chloride in an Erlenmeyer flask. So first of all, you need to know the formulas of these ions and their charges, and those are there right there. Silver is a periodic trend. It's a 1+ charge. Nitrate is a polyatomic ion. That's NO3 with a 1- charge. Calcium is in group 2, therefore it's a 2+ charge. And chloride, that's a halide ion, and that's a 1- charge. So you're going to take the silver 1+ charge and the nitrate 1- charge, absolute value of those two numbers, flip, bring it down, and you're going to get silver nitrate, that's AgNO3. And then you're going to take the calcium 2+ and the chloride 1-, and the absolute value of the 2 and the 1, and flip and bring it down, and you're going to get CaCl2. So those are my 2 reactants. And then you're going to look at your solubility rules and say, oh, nitrates with the silver nitrate, all nitrates are soluble, therefore the AQ. And then the next one, the calcium chloride. Chlorides, bromides, and iodides are soluble except for silver, mercurous, or plumbus. And calcium is not one of those, so therefore it's aqueous. Now you need to come up with the products. So the products are another set of Californias. That's a cation, anion. So the silver is going to combine with the chloride. Silver is a 1+ charge. Chloride is a 1- charge. I'm going to take the bull by the horn, flip, bring it down, and I get AgCl. And then the nitrate and the calcium are going to combine together. I'm going to always write the cation first, so therefore the calcium is written first as a 2+ charge. The nitrate is written second as a 1- charge. Flip, bring it down, and I got CaNO3 in parentheses and a 2 outside. Now I'm going to look at my solubility rules. So silver chloride, that's the AgCl. That's right there, the AgCl. That is chlorides, bromides, and iodides are soluble. That is aqueous, except for silver, that's one of them, which is a solid, mercurous, or plumbus. Okay? And then the calcium nitrate, all nitrates are soluble. So therefore the calcium nitrate is soluble. I'm going to balance this here really quick. There's 2s that go right there, and so that's good. Now what I'm going to do is I'm going to take everything that is aqueous, and then I'm going to break it apart into their respective anion and cations. Cations and anions, okay? But the thing that's a solid, I'm going to keep that alone because that's a solid. It's a precipitate. It's stuck together. So now I'm going to take everything that's aqueous and break it apart, okay? Now I'm going to scan on both the reactant side and the product side. You do notice that the silver chloride that's on the product side is still stuck together. That's the only one that is not in an ion. Okay, that is a solid. That's a precipitate. Okay, now I'm going to scan everything on the horizon here and look for things that are the same, exactly the same on the reactant and the product side. They must be the same formula. They must be the same number of them, the stoichiometric coefficient, and the same charge. So the things that are the same are I have here highlighted in the pink and the yellow. The nitrates are the same on both sides. I got 2 nitrates on both sides. I got 2 calciums on both sides highlighted in the yellow. Okay? Now I'm going to take everything that is not highlighted, and I'm going to take those and I'm going to bring those down and then reduce them, and then I get the following. So that is silver 1 plus ion, that's aqueous. Chloride 1 minus ion, that's aqueous because I have a cation and an anion. And then I have one product, that's the silver chloride, that's a solid. You should see that the calcium ions and the nitrate ions, both the calcium ions and the nitrate ions, are no longer in the net ionic equation that's on the bottom. The calcium ions and the nitrate ions are called spectator ions, or common ions. So spectator ions or common ions are not included in the chemical reaction whatsoever on the net equation. So think about it this way. If you're at a basketball game and there's players down on the court right there, okay? The players are important. Who are the players? The silver ion and the chloride ion, and they make the game, and the game is silver chloride. But if you were to buy a ticket and you're to sit in the stadium, you are a spectator. You are not involved in the game that's on the court there. So that's why spectator ions, it doesn't matter if you are there or not there, that game will still go on. If you change that ticket and give it to your friend, the game will still go on regardless of you being there. But what's important are the players, and the players are the silver ion and the chloride ion in this example. Okay, let's do net ionic equation number 2. So here's net ionic equation number 2, that's sodium hydroxide and ferric chloride. Again, you need to know the trend charges and the polyatomic ions here. There's only one polyatomic ion, that's hydroxide, but you do need to know the trend charges of the others. That's sodium is a group 1, hydroxide is a polyatomic ion, and there's ferrous and ferric, and ferrous is a 2 plus charge, ferric is a 3 plus charge, chloride is a halide ion, that's a 1 minus. I'm going to take the 1 plus charge on the sodium, 1 minus charge on the hydroxide. Absolute value of those, bull by the horns, flip or bring it down, and I get NaOH. No parentheses required. Then I'm going to take the Fe 3 plus charge and the Cl 1 minus charge. Absolute values of the 3 plus and the 1 minus, and then flip those numbers, bring it down. I got FeCl3. Both of these two things are aqueous because if you look at the sodium hydroxide and look at your solubility rules, all sodium compounds are aqueous. There are no exceptions. And then with the ferric chloride, chlorides, bromides, and iodides are aqueous except for silver, mercurous, and plumbus. Okay? Now we need to come up with the products. So I'm going to take the sodium, that's a 1 plus, and the chloride, that's a 1 minus. Take the bull by the horns, absolute value, flip, bring it down, I get NaCl. I'm going to look those up on the solubility rules, and sodiums don't need to include those because there are no exceptions. Okay, and then I'm going to put the iron first because that's the cation and that's a 3 plus charge. The hydroxide second, and that's a 1 minus charge. Flip, bring it down, and I'm going to need parentheses on this one here. Then I'm going to look at my solubility rules. Okay, in the lower right-hand corner of the solubility rules that I had on a previous lecture here, okay, the hydroxides are insoluble except for ammonium ion, that's NH4 1+, or the alkali metals, which are group 1. So ferric hydroxide is a insoluble precipitate. That's why there's a solid right there. Okay, now I'm going to do a little bit of a shortcut from the previous one. Although we're going to get the same answer, you should try to do net ionic equations number 1 in this same fashion. I'm going to look on the product side and figure out which one of the products is a solid, a liquid, or a gas, and then I'm going to bring that down. Okay, so what's the solid here is the ferric hydroxide. That is the solid. Okay, now I'm going to ask myself, how did I get to ferric hydroxide? That is the solid. How did I get to that? What did I use to acquire the ferric hydroxide? I used an iron that's a 3 plus charge and a hydroxide that's a 1 minus charge. So that's going to be on my reactant side. Now I need to balance this. How many irons do I have on the product side with the FeOH3? I got 1. So there's a 1 in front of the ferric on the reactant side. And then FeOH3 parentheses, that product, how many hydroxides do I have? I have 3. So I'm going to put a 3 stoichiometric coefficient in front of the hydroxide. And bam! That is my answer for the net ionic equation. Notice that I have 3 hydroxides and I have 1 iron. And that those are on the reactant side. On the reactant side, both of the reactants are in the aqueous state. And on the product side, I have my single solid. I want you to notice something else, that this actually balances for charge and for mass. I already did the mass balancing, 3 hydroxides on both sides, 1 iron on both sides, but I didn't do the the charge balancing. On the product side, the net charge on that ferric hydroxide compound is a charge of 0. Okay? And then on the reactant side, there are 3 1- charges. That's a total of a 3- charge for the hydroxide. And then the iron 3+ charge. Okay? That's a total of a 3+ charge. If I were to add 3- and 3+, I get a 0. So this is balanced for charge and for mass. Okay? Good. So then the other question is, on the previous one, I pointed out the common or the spectator ions. So what are the common or the spectator ions in this example? So the common or the spectator ions are not involved in the net ionic equation. They are not the players. So I want you to look in the upper right-hand corner there and figure out which ones are not involved in the net ionic equation. That's correct. That is the sodium and the chloride. The sodium and the chloride are not involved in the net ionic equation, so therefore they are the spectator ions. Okay, fantastic. So that was the 5th video in a series of 5. Hopefully my microphone is working here today and you can hear me, okay? Major tone, okay? So I hope you had a great time with this unit, chemical reactions. Review all of them so that you get them all. Make sure that you do lots of practice with balancing of chemical reactions, okay? I'll see you later. Have a fantastic day.